All right, good evening, everyone. Yeah, I didn't expect that I will see you again so soon. I guess you are the same, especially for L2 students. we just finished the class this afternoon, and within 3 hours, yeah, we meet here again to continue this lecture on advanced Python programming. Thank you for attending this additional lecture class, and also thank for the online students. So yeah, I guess the online students, if you have any question you would like to ask during the whole class, you can just type your question in the chat box, or maybe you can raise hand in the Zoom so that I can see that. All right? Yeah. Welcome to this additional class, and welcome to the evening of Python. This will be a very long night. We know we will have 2 hours of all this Python programming stuff. Not easy, but yeah, please try your best to focus, and we will just follow it, and then hopefully everything will get clear so that you will be well equipped of all this programming knowledge. All right, so let's start. So recall that in last class, we end up with the OOP, with Python programming. We introduced how to define a class in Python. The class is an OOP object, right? And then after you define class, how to create an object from that class. Also, outside of class, how to call a class method, how to access some class instance variables. So we covered that. At the end, we also covered about the private and protected members in a class. So that is, even though when you define a class, like everything is by default public, but still if you add some prefix, the single underscore or double underscore, you can make the instance variables to become protected or private. After that, you are not legally allowed to directly access or modify their values outside of class, but still we can do that through the accessor and mutator, like I have shown in this example. So basically that is what we have covered today. And let's continue. The next content would be about the class variables. Yes, I know, confusing, right? Before we learned class instance variable, now we have a new concept which is called the class variable. Then what is this class variable? Yeah, it's definitely different from the instance variable. So now a class variable is a variable that is defined within a class and outside of any method. If you recall the previous instance variable, all the instance variables, actually they are defined in the constructor or the init method, right? So for example, just look at it. This is an instance variable, self.double_name. The instance variable must be defined within the constructor. Constructor itself is a method of the class. But now for class variable, it must be defined outside of any method, but still inside the class. And it is a variable that is shared by all instances of the class, or we can say all objects of this class you have created. And meaning that if the variable's value is changed, the change will be reflected in all instances of the class. And the class variables are accessed using the class name instead of the object name, followed by the class variable name. So let's see a concrete example so that you can understand what I'm talking about. So here again, we have our Pokemon class, but note the difference here. We define a class variable here. It's called the num_Pokemon. So we just initialize it to be 0. So at the first time, like num_Pokemon equal to 0, this is a class variable. It's defined. Yes, please.
Can you turn off the lights because I feel like kind of difficult.
Okay. Yes, very good points. Actually, I also find it's very hard to look at this for me, but I need to know which light it's. Okay. Is it okay if in this way? Much better. Okay, thank you. Thank you for pointing it out. Yeah, I also feel that it's very hard for me to see it clearly, and I only have these 3 screens to refer to. So yeah, because my screen is like in the chat box of Zoom. Yeah, thank you. Yeah, let's continue. Now we have the class variable. As you can see, it's defined inside the class, a non-variable, but it's outside of any method. It's not inside the method, right? Another difference you may pay attention to is that now there is no self-dot as the prefix of this variable. Unlike all the other instance variables that are some variables must be self-dot within the class, but now class variable, like we never use this self-dot because it will be shared by all the objects of the class instead of by any single object. This is a class variable, and we have our constructor. This is the same with the previous example, the init constructor, and excepting from we initialize all of private instance variables, like here, we still initialize assigned values. We have another statement inside this constructor. Yes, it's okay you write some other statements in the constructor. Of course, constructor should initialize instance variables, but it's not the only thing that a constructor can do. If you want to have some other statements, it's fine, put it in the constructor. Like the constructor statements will be executed whenever you create an object of the class. So inside this constructor, we have another statement, Pokemon dot non-Pokemon equal to the previous value plus 1. So this plus equal 1 means that it will just be added with 1. Now we access such class variable, and as the previous page said, if we want to access a class variable, we access it using the class name Pokemon dot connected with this class variable. It's never self-dot again, it's class variable. So clearly you can see the expression of the differences, right? Instance variable, you need to write self-dot. For class variable, you need to write the class name Pokemon dot, and we execute such line of code in the constructor. The other will remain the same. This print method, we just keep it here. All right, this is how we define a new class Pokemon with the class variable non-Pokemon. Then let's see how we will use that. First, we create an object warpix from the class Pokemon. So we assign values warpix 0037 file to it, and we create another object which is called the Togepi. Here, Togepi is another object created from the Pokemon class, and we assign all the values Togepi 0175 Fairy. Now we created two objects from the class Pokemon, and if we print the information like warpix.print, Togepi.print, of course we can get the information of the two Pokemons, like print their information here. And last, we print total number of Pokemons by accessing this class variable Pokemon.non-Pokemon. Within the class and outside of the class, we all access the class variable using this way, class name Pokemon dot, and together with the class variable name, and we can get that total number of Pokemons 2. Yeah, I guess you know the reason why it's 2, right? Initially, it's 0 here. And after we create this warpix, it goes into the constructor at Pokemon.non-Pokemon with 1. So that means after this line of code, warpix, now the non-Pokemon becomes 1. And after this line of code, this code, Togepi, after Togepi, we again go into the constructor. So this line of code will be executed again, and now this non-Pokemon will become 2 after we created 2 objects. This change on the class variables will affect all the objects you created, affect all the instances of the classes. And basically, you can see the function of this class variable, non-Pokemon, right? This class variable, Pokemon.non-Pokemon, is used to record the number of Pokemons you have created from this class. And this is the usage of class variable. It's not only belonging to any single object, it belongs to all the objects created from the class. Yeah, some students asked in the Zoom that will this lesson be posted on Canvas? Yes, the recording will be posted on Canvas, so no worry, no worry. And also the lecture slides, we still use the same one, so you can access all the materials. All right, so this is an example of a class variable. Let's see the comparison between the two confusing terms, class variable and instance variable. The class variable is defined within the class, but outside of any methods. And then for the instance variables, it's defined within methods. Of course, typically the constructor. We know that we should initialize. That means we need to define and assign some values of the instance variables inside the constructor. Then the scope of class variable is that the changes are made to the class variables affect all instances. Like previously, we can see the Pokemon.non-Pokemon is affected, right, for all these instances. But for the instance variable, the changes made to the instance variables does not affect all instances. That means if you make some changes to WAPIX regarding the instance variable, but of course for this example, it's not a good example to change because in this example, we don't define the accessors and mutators. But if we have defined accessors and mutators, we can do that. And if you change any instance variable of WAPIX, of course, it won't affect Togepi, right? Because these are two different instances. If you change instance variables, nothing to do with some other instances. And for initialization, note that for class variable, it can be initialized either inside the class definition or outside the class definition. In this example, we initialize it inside the class definition. That is, at the beginning, we initialize it to be 0, but it's also fine if you just initialize it outside of the class. It's okay. But for the instance variables, typically initialized in the constructor of the class. And this is how we deal with that. For the access, if we want to access a class variable, please access it using the class name, then followed by the variable name. So that's class name dot variable name. But if you want to access the instance variables, you need to access it using the instance name followed by the variable name. That's instance name dot instance variable name. And inside the class, of course, that just simply becomes self dot instance variable name. And last, the usage. The class variable is useful for storing data that is shared among all instances of a class, such as constants or some default values. Like the previous one, we used that non-Pokemon to just record all the number of objects we have created. But for the instance variable, it's used to store data that is unique to each instance of a class, such as some object properties, like the name, index, types. There are some unique properties to each object, right? So we use instance variable to store this information. All right, this would be the comparison between class variables and instance variables. So before we go into inheritance, any questions so far regarding class variable? Great. Next, we will talk a little bit about inheritance. Inheritance overall is a complicated topic in Python, and I believe in some other programming languages, inheritance, like if you want to make it complicated, it can be really complicated. But for our course, we will only cover a little bit, so not so deep about inheritance, so that you can know some basic concepts and usage of the inheritance. Now, inheritance is a mechanism that allows us to define a new class based on some existing classes. All the attributes and methods of some existing classes will be inherited by the new class if we use inheritance mechanism. The existing classes are called superclass or parent class or base class, while the new class inherited the properties is called subclass or child class or derived class. So let's look at the syntax. So if we want to create a new class based on some superclass, we use such syntax. Give this subclass name here. So you define a subclass name, and inside the parentheses, you need to give it the superclass name. If you use it in this way, then that means now you will create a subclass which inherits the superclass. And inside this subclass, the first thing you do is, again, to implement a constructor. So still you need to have this init. It's a constructor. And for this init, it takes self and some arguments as the parameters. Then the very first thing, actually it's okay sometimes that you don't follow this rule to use inheritance, but it's the way that we recommend you to do, because this can avoid many bugs and many errors. So if you want to build up the constructor for a subclass, the very first step we recommend you to do is call this line of code. That is the super.init, and give some attributes, the related attributes to the superclass. So that means before you initialize any new arguments, any new instance variables for this subclass, first you initialize or you invoke the constructor of the superclass. You first initialize those things, those attributes. So let's say after this one, actually it directly goes into the superclass constructor and call that method, call that init method, so that now you will have the initialization of all the instance variables that you inherit from the superclass. All right, then let's see what next. Next is that you still need to check whether there are some new instance variables in this subclass. So if anything that is new that does not occur in superclass, you still need to do initialization like this. And after that, you complete to initialize all the instance variables. And of course, you can define your own method. Note that the subclass actually will inherit the methods in your superclass. But still, you can define some new methods here like this. So again, you define some method name and give some arguments and then execute some statements. So this would be the syntax of subclass, how to create a subclass from the superclass. So let's see an example here. Our Pokemon class again. So we have this Pokemon class, and this is its instructor. It has 3 private instance variables. Then for each of the instance variable, we define the getters and setters, or accessors and mutators, because they are all private, right? And also we have this print method. This is our superclass or parent class. Next, we will create a new class, use the inheritance mechanism so that it can follow such Pokemon class. And now we create a new class. So define a new class, which is called the evolve Pokemon, and that inherits the Pokemon class. So as you can see, we follow the syntax. Yes, some students asked in the Zoom about the constructor for superclass. So later on, I will explain it again. So I believe that maybe you can understand more through this example. This example is that we get the name of this subclass, which is the evolve Pokemon. And inside the parentheses, we invoke Pokemon, the class we defined just now. And by using this way, that means now we will create a new subclass, evolve Pokemon, to inherit the Pokemon. Okay, now it goes into constructor. The constructor, I think this can also explain the online students' questions. In the constructor, init self, of course, we need to put it here, and all the arguments like name, index, types. Actually, we know these 3 arguments are from the superclass. Now we add a new argument here, which is called evolve. And in this evolve, we by default, we assign the value Rachel here. All right, this is the constructor. Then inside the constructor, the very first step we will do is we invoke the superclass constructor. So that means we get this super dot init and pass this name, index, and types to this superclass. And after that, know that it will goes into the superclass constructor. That means goes here. After it goes here, and it receives the name, index, types, right? Because here we give this name, index, and types to the superclass constructor. So it receives the 3 arguments, and then it will do the initialization because we invoke this constructor. So inside constructor, it initializes these 3 private instance variables, assign values to them. Yeah. But we haven't done yet. We haven't done for the subclass because for the subclass, now we want to define a new instance variable. That's the self.double_evolve, and we assign the value evolve to this self.double_evolve. So now it has a new private instance variable. We need to initialize it because it's not in superclass. We have to do it manually for this subclass. And after that, we finish the constructor of the subclass. Next, we notice that there are quite several private instance variables, and we know as a responsible programmer, I'd better write some accessor and mutator for each of the instance variables. They are private. Do I really need to do this for each instance variable? No need anymore, because in the superclass, we already done this for 3 variables, right? For name, index, and types, we already defined their accessors and the mutators. And now, in this subclass, we only need to do it for the new instance variables. So as you can see, actually, we only define these 2 new functions, like define the getEvolve, so we return self.double_evolve. So we can access this new private instance variable, and we also define a mutator for it, so that if we want to change its value, we can call this getEvolve, pass a new parameter evolve to it, and then change self.double_evolve to be this evolve. And we are not enough yet because we expect something more. Previously, we already have the print method. Print method is that we print the Pokemons information. We can successfully print the 3 instance variable values. Now that we have a new instance variable, why not add this new instance variable to print it out? So we will define a new method print, and as you can see, actually this print has exactly the same name with the superclass print. It's legal to do this. It's okay that you write a new method which has exactly the same name with your superclass. If you do this way, then actually this subclass print will override your superclass print. So that means if you call the print for this subclass, then actually it's called this function. Call this function instead of the previous one because you override it. All right, so in this new print function, first we invoke the superclass print because actually we can still access all the superclass methods currently. So we run this one, super.print. In this way, it goes back to the superclass and execute these lines of code. So it will print all these things. Then after that, we want to add a new information. So after that, we also print evolve into and concatenate it with self.double_evolve. So that now we can print the complete information of the subclass instance variables. So this is how we can define a new class using the inheritance. So again, the key points is that first, inside the parentheses, you need to put the superclass name, of course, to claim that you want to do the inheritance from such a superclass. And in the constructor, you need to first invoke the superclass constructor, and then you can do your own initialization. And after that, you can create some new methods, like as many as you like. If you use the same method name, then it overrides the previous ones. So let's see how we use that. All right, we define an object which is called the jiggle path. The jiggle path is an object of evolve Pokemon. So we give all these as parameters like the jiggle path, jiggly path, and 0039 normal and wiggly path. These 4 parameters to evolve Pokemon, so that we indicate, okay, the name, index types, and evolve are being like this. And after that, we call the jigglypath dot print this method. After that, it goes into this method, right? Because we call the subclass print. And then after it goes into this print, first it will goes into the superclass print. So it returns to here. So it prints all these 4 lines. So it prints that print Pokemon, a name, index type, and after that, execute this line of code. So it gets evolved into Wigglytuff. So this is how we use the inheritance to create some new class. So yeah. Some online students ask that whether the subclass inherits the functions of the superclass or only the variables. It will inherit the instance variables as well as all the methods. So it must inherit the methods, right? Otherwise, we cannot call this super.print. So now that, as you can see, we call this super.print, that means it already inherits the superclass print method, so that it can directly use it. Yes, this is the example. So any questions so far regarding the inheritance? Yes?
Inside the init constructor,
Yes.
why do we have to write the instances like name, index type?
Oh, name, index type. Yes, very good question. Because there in this super.init, you need to identify which parameters you want to give to the superclass constructor. Because here, actually, the superclass need to receive 3 parameters, right? Name, index, types, these 3 parameters. And if you don't give it to this constructor, actually, it cannot figure out which 3 parameters it should receive. So yes, in this superclass, if you want to invoke the superclass init, you still need to clearly identify the parameters for the superclass init. Very good question. Thank you. Yes. Any other question regarding the inheritance? Yes, please. Sorry. Move the.
Remove like the index from the from this.
Oh, you mean if there is no index in the subclass? Oh, yeah. If that's the way, actually may cause some problem. Of course, you may also try to fix it, but basically, if there is some index missing, then that means now this superclass cannot receive a parameter, which it requires. Usually, if you write in this way, then that means possibly in this subclass, you simply want to drop this information. You don't need to maintain it anymore, right? It's okay, it's okay. Actually, it's okay. Then if you're already for sure that you won't use this information anymore, you can simply drop it, but still you need to pay attention to fix it in this one, because we already know this superclass constructor requires 3 parameters, name, index, and types. Now you only pass 2 of them. You only pass 2 of them, then you need to use the keyword arguments. That is, I think you need to write something like this. I can try to, yeah, not very easy for me to see that. Okay, just give me a few seconds. I guess I will directly do the mirroring so that I can directly modify here. Display. Okay. All right, yeah, I think then we can all use the same one. Great, and put it. Okay. All right, yeah, then I can easily modify that. So if in that case, I write it here, maybe I'll give it some larger. Okay. Init and name equal name types equal. Sorry for the type. Okay, in this case, if you simply want to drop that information, that index, then you can try this thing, super dot init, name equal name, types equal types. Here name, note that even though we keep this name equal name, but the two names are totally different things. The first name is the keyword for the superclass argument, because it must have this name. This is a keyword argument. So here, the first name is that keyword argument. Then the second name is the parameter value you pass to the subclass here, this name. And similarly for the types, the first types is the keyword argument for the superclass, right? It requires such keyword argument. The second types is what you receive for the parameters of this subclass construct, these types. So basically it means that now we will assign the values name, this name, to superclass keyword argument name. And we will assign the types, these types, to the superclass keyword argument types, and we drop index. This works because in the superclass constructor, we assign the default value index, which is 0, 0 to 5. And if no parameter values are given for this index, it will use these default values. However, pay attention to that. If we do not have the default values, for example, if we simply write in name, index, types, and we do not provide the default values, then it will raise error. Because now one parameter or one argument index cannot receive any value if you do not give index. So yeah, this would be like, yes, if you simply want to drop some instance variables for the subclass, it's also okay. But still, you need to fix some possible bugs. You need to make sure that in the superclass, there are some default values, even though for the subclass, you will never use the instance variable, but you need to make sure it won't cause any error in the superclass. It must receive some value, or it has some default value for the instance variable. Very good question, thank you. Any other question regarding the inheritance? So maybe I can also check here. Okay, quite a lot. One by one, if we don't mention the index parameter in the init of subclass, but mention it in the super.init, then will it take the default? Yes, one student already, yes, it will take the default value of the superclass, quite good. Will the edited PowerPoint slides be posted in the course website? Yeah, I think I can. Like after the class, maybe I will also post this edited. All right. Any other question regarding inheritance? Great. Actually, there are many interesting things about the inheritance. For example, can one subclass inherit two superclasses? You may have a guess. Can we do that? Yes, we can do that in Python. But yeah, if it involves like multiple superclasses, the things might get much more complicated. So for our course, we only cover this one superclass, one subclass, such a thing. And yeah, I think actually for COMP2211 all the lab and assignments, actually you don't need to use the inheritance mechanism, but still it's good to know that. It will be very helpful for your later on projects, I guess, if you want to create some subclass. All right, basically that's all the contents I would like to introduce about OOP. Next one would be importing libraries and data. Importing libraries and data are very, very important to write an AI program. Basically, writing an AI program starts with you know how to import libraries and data. So first, let's get familiar with these three concepts: modules, packages, libraries. A module in Python is a bunch of related code. For example, there can be functions, classes, variables. They are saved in a file with the extension .py. So basically, as you can see, a module is a Python file. And there are some related code bunched together. And then package. Now, a package is basically a directory of a collection of modules. And the last, library. A library is a collection of packages. So they are in different layers. Okay, I don't have the example here. But you can see that basically we have a library. And then inside a library, you may have multiple packages. So there are many packages in a library. And inside each package, you may have multiple modules. So they're in different layers. And then we can try to import library or package or modules so that we can directly use this already well-written code. And we will use one keyword, which is called import. So in Python, we directly use import to indicate that, okay, now we will import something. It's the most common way to access some external modules. And modules, we already know that they are Python files that contain some functions, classes, and variables so that you can reference in your program without having to write them yourself, because like all the functions, they are already written by others. You directly use them, it's okay. And this is how you get access to machine learning libraries. Yes. For machine learning, we typically will use these ones like NumPy, Keras, scikit-learn, TensorFlow, Pandas, PyTorch, Matplotlib library. All these, actually, they provide lots of useful modules you directly use. You don't need to write it by yourself again. And import, of course, if you already take COMP2211, you know that in C++, you write something like this, right? Include something. But now in Python, we do not have this include keyword. We just use this import to replace that. So, but basically, they are very similar. They are used in the same way. However, usually, we don't need to import all of the modules. Like inside a module, possibly there are so many functions. You do not need everything. We only need to import a few functions from each of those modules. In that case, we use another keyword, which is called from. It's like here. From, we from some module import some function, so that we only import the exact functions that we want to use in the code. The syntax is like this: from some module import function or class or variables. So these are the two keywords, from and import. And we can also use this one, from some package dot module import some function or class or variable. This is how we use that. Let's see some example here. Now, we only want to import a square root function from the math module. Then we simply do this one, from math import square root. Now, even though inside this math there are so many functions, but after we run this line of code, we can only use square root function from math because we only import this function, and we can use it. So we define a variable x to be 100, and after that, we print square root x, it will print 10. So after we run this line of code, it sees a function square root, and then the Python will check that where does this square root function come from, and it will find that, okay, actually we already import square root from math. So it will use the math.square root to compute for this line of code. And there is also another syntax, it's like this, from some module import asterisk. This asterisk is a magic symbol, means everything. Actually, I think it's not only for Python, in some other languages or in some like terminal commands, actually this asterisk also means everything. So if we run this one from some module import asterisk, then it means that we want to import all functions. We want to import everything from this module. So this will also work. If we replace it with from math import asterisk, then basically that means we will import everything from math, includes the square root function. So we can directly use it like this, print square root of x. In this way, even though you may find that, okay, it seems that we haven't claimed what is square root function, but it's doable because this square root already contained in this asterisk is everything. All right, so yeah, check questions. All right, one student asked that when two modules have a same function name, like both name printing, so a good practice is still do things like input. Yes, very good question. Later on, I will talk about example about that. That actually it's possible that from two different modules, they have two functions calling the same name. It's possible. Later on, I will introduce an example of that. What is the advantage of doing this over just importing the entire library? Good one. Actually, I think this question is related with the last question. Why not just always import everything? This is because usually we are not only use one library. Usually we may use two libraries in the same time. If for all the libraries we import everything, then possibly that the two libraries will have functions calling the same name, right? And after that, they will crash with each other. So that means when you call a function, actually you don't know where does this function come from, this library or that library. That's why typically, if we specifically know which functions we will use, then we just import those functions. We won't import everything. Import everything is convenient, but sometimes just cause this crashing of different libraries. Yes, very good. Actually, these two questions are just related with each other. Yeah. So yeah, here is the explanation. What I mentioned before is that we should generally avoid importing everything. Since we do not know if the square root function is from the math library, if we just import all syntax for the multiple libraries, we may end up with the clashes or ambiguity, which decreases the readability of our codes and sometimes make it very hard to spot the errors. You'll never know where these errors come from. Like an example, suppose we import everything from math module, from math import asterisk, and then we import asterisk from C math. Note that C math is another module, which also a module providing many useful mathematical functions. And note that there are two functions in the two libraries which call exactly the same name, SQRT. Both means square root. So actually the math has such a function, math.square root, and CMath has another function, CMath.square root. So okay, two functions calling the same name. Later on, we run this x equal to 100, and then print square root of x. It prints 10, of course, but we don't know. Typically, we won't know which function it's using. It might use the math.square root or CMath.square root. We don't know. But for this one, actually, I can tell you that this one uses CMath.square root. And which is a different implementation to math.square root. Of course, here x is integer 100 and the square root of 100 is 10. Everyone knows that. But for some cases, it's possible that you will end up with different results if you use two different functions from the two libraries, because still they will have some slight differences in the implementation. So please pay attention to that. Please do not import everything, especially you are using multiple libraries. Try to be specific. Try to provide the names of the concrete functions that you want to use to avoid this clash. Yes. All right. So any questions so far about importing? Great. No question. Let's go on. Here I would like to introduce the scikit-learn. So one of the most frequently used machine learning library is scikit-learn, as I already introduced in, I think, in lecture 1. For instance, now we want to use k-means algorithm. It's okay you don't know what is k-means. A few weeks later, you will know that. A few weeks later, we will just cover what is k-means. But now you just want to use the k-means algorithm, even though you don't know it until now. So we want to use k-means algorithm, and we found that, now the scikit-learn already provides the implementation of k-means and provides such modules so that we don't need to implement k-means by ourselves. We don't need to do it from scratch. We can directly use it. In this case, of course, we need to import the corresponding module, and then we need to use it. And usually, we recommend you to do this thing. Look at documentation. Always look at the documentation if you want to import some functions or some modules, because you need to look at the documentation to know how to use it. So, for example, after this documentation, we find that this is the syntax for the k-means. Here, of course, if you're interested, you can just click into the k-means, try to understand it, the documentation. But since now, actually, you haven't learned what is k-means, I guess still it will be hard for you to understand what these parameters represent. Don't worry, we just show you as an example how to use it. Okay, so the meaning of all the parameters, they don't matter for now. The name matters. So that means it matters that we know the k-means is actually in the library sklearn in this package cluster, and the module name is called k-means. And for the k-means, it should receive these keywords arguments: unclusters, init, uninit, max iteration, and so on and so forth. So, okay, now we get all these keywords names. Here we notice there is a dot here. The dot refers to accessing something inside a package, or it indicates the layers of the modules. So that's why we see scikit-learn itself is a library, then package, then modules. Yeah, actually, this is the layout I would like to show you before. The layout of scikit-learn, of course, just some parts of it. The scikit-learn's layouts are very huge because it provides so many implementations. Scikit-learn itself is a library, and then of course, this library has its own constructor, as you can see. Even though you want to get a library, you still need to write constructor. And inside this library, it has many packages. Here, cluster is a package. Linear model is a package. Neural network is a package. Then inside each package, there are many modules. Like inside the cluster, we have k-means as a module, spectral clustering as a module, affinity propagation as a module. All these are already implemented. You can directly use it if you import it. You may also notice that the layouts do not strictly follow that library, then package, then module, because some modules are directly under the library. Like this discriminant analysis, this module is directly under the library of scikit-learn. It's not in any package, so it's also okay. So it does not really follow that you must have a package and then you write some modules. This is a simplified layout. And then go back to the k-means, okay? Remember now, we just want to use this k-means. In order to use this k-means, we have so many ways to import. really so many. You can choose anyone you like, but if you choose one import, then the corresponding main programming codes will be different. We can import scikit-learn.cluster. If we use this one line of code, then that means we will import all the modules inside the package scikit-learn.cluster, and including but not limited to the carrier spectral clustering affinity propagation. Basically now, everything under the cluster will be imported if you run this line of code. Another way is you can try to be more specific, of course, then import scikit-learn.cluster.k-means. Now that means we only import the module k-means inside scikit-learn.cluster so that you cannot access any other module of the cluster, just k-means. This is more specific. If we want to call the k-means on our data, we need to call this one, right? This is the most specific one, but you may already find that, oh, it's such a long function call. That means after you call this, whenever you want to create an object of this k-means, you need to finish writing this one. Show you an example here. So for the second usage, if you import in this way, now you want to create an object from this module k-means. For example, the k-means, this is the object you create, which is from the k-means. Then each time you need to write something like this, sklearn.cluster.k-means. Each time you create an object, you need to write something like that. That is, you need to write the complete information of this k-means from the library to package to this module. Quite long. So typically, we declare everything but the name of the actual module in the import. So typically, we use this way, from scikit-learn.cluster import k-means. And that means now we want to import the module k-means from the package scikit-learn.cluster. After that, if you want to create an object k-means, it's much more convenient. You only need to write k-means equal with k-means. Of course, the second k-means you have to big capitals because it must in accordance with this module you imported. So this k-means equal with big K, big M means, and you give some parameters. The reason is that for Python, the real name that you want to call is the name followed of the keyword import. So that means after import, here it's followed with sklearn.cluster.k-means. Then Python only accepts it as the name of the module you want to call. But if you write something like this, then after import, after this keyword, the name is k-means. Then k-means is the legal name that Python accepts to use this module. So the name after import matters. So that's why after we import in this way now, things become much easier, right? You don't need to write for such a long expression. All right, but you may say that I still think it's too long. Each time I have to type this 1, 2, 3, 4, 5, 6. I have to type these 6 letters to create a k-means object. I don't want to do this. K-means are too long. This name is too long. Can I further shorten it so that it will become a very, very, very easy name? Yes, you can. And we introduce another keyword, as. If we use such keyword as in some import command, then that means we want to create an alias, or you can say we create a nickname to use in place of the original and possibly very long function name. So we do something like this. From scikit-learn.cluster import k-means as km. So in this way, we create a nickname km to represent the real k-means After that, if you want to create an object k-means, simply write something like that. K-means equal with km followed by these parameters. So you may find that, oh, it seems that we have a new rule. Previously, we said that the name after import matters. Yes, we have a new rule which has a higher priority, is that if in the import expression there is a keyword s, then the name after the keyword s has the highest priority. Python accepts this name as the module, as a legal expression for that module. Maybe we can try to summarize the import rule here. So actually, it's some top-down rules. So that means the rule 1 is the highest priority. Rule 1 is that the name after keyword s is the name that Python can accept, that you can use. And rule 2 is that if no keyword s in the import, then we refer to the name after import. Sorry for the typo. All right? Yes, so we have these two rules to import these things, and which name you should refer to, you should use in order to call the modules. First, to see whether you have as keyword. If no as, then try to check the import. Because of course you must have the import, right? In any import expression, you will have this import. So any questions so far regarding how to import libraries and modules? Great. Yeah, I hope everything is clear to you. Then next is about, maybe move this thing up. Okay. Next would be how to import and export data. Of course, to write an AI model, library is important. Library helps you to implement your model, but the data is also important. If you do not have like data, and basically your model is just an empty model, does not have any data. So here, your data can come in many forms, which are too exhaustive to list here. Like your data might be in text form, might be in image form, might be in different kinds of form. There are so many different types of data. Here, we will typically introduce how to deal with data in CSV. That's the comma separated values form. Or basically, that's the data you can open with Excel, the CSV data, right? Since that is fairly common, usually in machine learning and in AI, we will store the training data and testing data in some CSV files. In CSV files, because it has explicit rows and columns, and usually we will see that each row is a data point, each column is a feature, so that we can clearly represent the data. Another reason is that CSV is well adapted by a library, Pandas. And Pandas, basically, for all the AI beginners, and even for the very mature AI developers, AI researchers, Pandas is a useful library to deal with the data. So here we introduce the CSV. So in Python, most data manipulation is just done with the Pandas library. So let's see how to import data. So now consider we want to import the data from Google Drive, of course, in Google Colab. So that means, suppose now we are working on the Google Colab. Note that if you are not working in Google Colab, for example, if you work in your own environment, in your VS Code, in your PyCharm, then basically you cannot mount your Google Drive. Only Google Colab provides such things, because Google Colab and Google Drive, they both belong to Google. That's why Google Colab can do such thing. But if you are in your own VS Code or PyCharm, it's possible that this doesn't work, because there will be some security risk that Google Drive just don't allow you to do this thing. But now assume we're already in Google Cloud, and now we want to mount our Google Drive directory because we want to use some data we already stored in Google Drive. Then we can run this line of code. So from google.collab import drive. Specifically, you can use it in Google Cloud. And after that, drive.mount and go to this directory. This is the main directory in your Google Drive. If you run this line of code, then it will ask you to visit a link to allow Google Cloud to access your Google Drive still because there is some security risk, so it must get your approval on the consent. And after you click yes, I want to mount my Google Drive, then it will guide you to your Google Drive directory. And afterwards, the drive files will just be mounted, which you can view in the sidebar to the left in Google Cloud. And if we want to access a file which is called trainingdata.csv in the root Google Drive, in the root My Drive folder, of course, assume that until now we already have this trainingdata.csv in our folder, so we already stored it there. Then we can read it using pandas. So let's say we import pandas as PD. The knowledge we just learned, right? Now, everything in the pandas, if you want to access it, you need to use the name PD, refer to pandas, because you import it as PD. Next, we create a data frame, df. This data frame is pandas.readcsv, and after that, we give the path of the trainingdata.csv to this readcsv so that it can read it. And we give the index column value to be false. And later on, I will immediately show you an example to demonstrate what this index column means. So it's like this. So basically, this is what we talked in last page. First, we import drive from google.collab. After that, we mount into the drive. Of course, we also imported pandas. And then we get the data frame from the pandas.readcsv. We let the index column to be false. After that, we print this data frame, print df, and we get something like that. So as you can see now, the printed data frame contains 4 rows from row 0 to row 3 and contains 3 columns. 3 columns are name, index, and type. These are all the data we have stored. Or we can see inside this training data, we have 4 data points. And each data point has 3 features. Their features are just name, index, type. So basically, this is the terminology we use in machine learning. Don't forget that we set index column to be false, right? What this false means, if we set the index column to be false, then the current columns, these 3 columns, name, sorry, it's not score and remark, it's index and type. I forgot to update that. But these 3 columns will not be used as a column index. Instead, a new column will be added on the left with numbers starting from 0, 1, 2, and so on. So that means actually in our Google Drive, in our training data.csv, we do not have the leftmost column 0, 1, 2, 3. This index column is added by pandas if we let index column to be false. Let index column to be false. Now, no column will be used as index. Pandas will automatically add index 0, 1, 2, 3 to the leftmost. It does not belong to the data. It's just used as some index. And actually, it's very similar with the Excel. If you open any Excel, you will get the page like this, right? We can notice that in Excel, always there are some leftmost indices, like 1, 2, 3, 4. These are not data, right? These are not data you put inside. These are the Excel provides such indices to tell you which row you are at. And similarly, in pandas, let index column to be false, then it will add this 0, 1, 2, 3 as an index column. but it's not the data that you put in this training data. Then anyone knows what will happen if we let index column to be true? I guess you may ask that, because now that it's false, then we have such behavior. What will happen if we let index column to be true?
Maybe the name column from the index.
Yes, very good explanation. Actually, if the index column is not false, then we will need to pass the value so that some column will become the index. But it's strange, I know that. But if you let index column to be true, it will raise error. Because this argument index column, it cannot be true. It cannot take the value of true. It can only take the value of false. If you mean let it to be true, then you have to specify which value it should have. And instead of letting it to be true, this would be how we use that. For example, now we let index column to be 0. After that, if we print it out, it gets something like this. Compare with the previous one, the leftmost index column disappeared. Instead, this column, the name column, will be used as a column index. So that means actually now this data still it has 4 rows. Yes, 4 rows, but it only has 2 columns because the leftmost column is used as the index column. So that means name is an index, Pikachu is an index, Wapix is an index. It's not the data contents anymore. It's used as index because now we set the index column to be 0 to indicate that we want to use the first column as the index column. Note that index column can accept false as its legal value, can accept some integer numbers. The integer numbers will represent that which column you want to use as the index. It can also accept string values. So you directly give the string value of the column name like this. We can directly let index column be name. After that, it will extract the column called name, and it will find that, okay, this is a column, the first column here, which is called name, use this column as the index column. So actually, as you can see, it's the same effect with this one because the column 0 is just the column name, and they will be used as the index column. So this is the behavior of the pandas. So pay attention to that. Even though you use this function read CSV, but the index column affect a lot. If you use different values for this index column, basically your data will look very different. And the most common way is still like this. Let the index column to be false, because usually all the data we stored are the data we want. So just let the pandas to assign some index column by itself. So the conclusion is that we can assign false, integer refer to which column or some string, the column name to index column to indicate which column would be used as a column index. And it cannot be true. If you let index column be true, it simply reads error, tells you that it's some illegal value for such argument. After importing data, let's see how to export data. So that means maybe after running many lines of code, okay, now you get some new data. You want to save that data, right? If you don't save it, then it's gone. You do not leave it. So to save a data in the root, my drive folder again, you can do something like this. Of course, import pandas as PD. After that, suppose now we create a pandas data frame object output. Now this output has 2 columns. Note that now we create this data frame use dictionary, because the data frame actually can accept such dictionary as its values, and the key will work as the column name. Like the first column is called customer ID, and is numpy.array 1, 2, 3. So that means there are 3 things, 1, 2, 3. Or we can say that actually the data has 3 rows. And then the second column is called can repay loan. The value would be 0, 0, 1. All right, now we create a data frame object output consists of 3 rows and 2 columns. And we want to save it to our Google Drive. So here is how we do that. We directly use this pandas data frames method called toCSV. Yes, it's different with the previous one. Previous one, if we want to call readCSV, we call this pd.readCSV. This is because readCSV is a pandas method. But toCSV is a pandas data frame method. That means this must belong to some data frame object. Itself is not a method. It belongs to object. Or you can try to recall the OOP we have learned. And you can view it in this way. There is a class called data frame. Output is an object we created from that class data frame. For that class itself, inside this class has some class method called toCSV. So that's why now, if we want to call the class method, we need to call it output.toCSV. Simply, that's the reason. All right, this toCSV accepts first the content drive my drive long.csv. Basically, this is the path that you want to store your data, and the index, we simply let it to be false. The index to be false, again, it had the same effect with the previous one. That means you don't want to use any column as the index column. Simply let the index to be false. So this is how you can export data. All right, so any questions so far regarding importing and exporting data? Yeah, any question from the online students? If no question, before we go into the very essential part, NumPy, let's take a 5 minutes break. After the short break, we will go back and start with the NumPy. All right, let's continue. Yeah, received some questions in Zoom. Sorry, I didn't check that before the break, but yeah, let's answer it together now. One question is that if we use, I think refers to here, yes, import data. Yes, this example. One question is that if we use index column as 1, then index will be used as a column index. Yes, correct. Actually, you can try in Google Colab. You will find that if now we let index column be 1, then this index, this column, will be extracted and be used as a column index. And if you use this index column to be, like for example, the string of index, that had the same effect. Yes, very good. Another question, what does pandas.data frame create? Very good question, because for this lecture, actually, I do not specifically introduce the pandas due to the time limit, because if I also incorporate the pandas, then it will be a super long lecture. But no worry, I think following labs, maybe in lab 3 or lab 4, actually the TA will explain pandas to you. But now, yes, I would like to answer this question a little bit. What is this data frame? Good question. Data frame is the module inside pandas. Basically, the data object used in pandas is called data frame. So data frame only existing in pandas because pandas identified and defined what is data frame. So usually if we use pandas, we have to deal with all this data frame, and the object, data object in pandas is called data frame. And the data frame, what is this object? Data frame, you can consider it as yes, very like a CSV file. It has some rows, has some columns, and you have like many values in each entry. Basically, this is the data frame. It may also be somehow like the objects in other libraries possibly, but in pandas it's called data frame. And pandas data frame is adapting very well, almost perfectly with the CSV file. So that's why typically we just use pandas to deal with our data, because usually for machine learning, the data are stored in some CSV files. It's a very good question. Any other question regarding the contents before? Great. If no question, then let's go into the NumPy. Yes, our essential part. Because all the previous ones are some essentials for writing the more advanced Python, right? But starting from NumPy, it will be more related with that, the useful techniques that you need to use in AI. So in order to implement AI, definitely you will need NumPy. So what is NumPy? NumPy is a short for numeric Python and is a core library for numeric and scientific computing in Python. It provides some high-performance multi-dimensional array objects and tools for working with these arrays. Yes, as you can see, actually in different libraries, the data they're called in different names. In pandas, we call the data as data frame, but now in NumPy, we call the data as arrays. So array is a concept inside NumPy. And the arrays can be multi-dimensional. For example, here we have 1D array, 2D array, 3D array. We can even have higher dimensional array. Of course, we cannot visualize them, but still, NumPy can provide the multi-dimensional arrays. What is array? Here, a NumPy array is a grid of values, all of the same type, and it's indexed by a tuple of non-negative integers. Some keywords here, grid of values. So you can see a NumPy, also it has some entries, and inside each entry or inside each grid, there is some value. Another keyword, all of the values must be of the same type. And then there is index for NumPy array. So they must be indexed by a tuple of non-negative integers. And for NumPy index, follow the Python convention. The index starts from 0. So 0, 1, 2, 3, so on and so forth. And we call the number of dimensions as the rank of the array. And then for each array, it also has a shape. So here the shape of an array is a tuple of integers giving the size of the array along each dimensions. So we can see some examples here. In these examples, we try to initialize some NumPy arrays from nested Python lists and then access elements using the square brackets as index. Usually we will start with creating array from lists because I believe lists are something you are more familiar with, right? So actually you can directly get an array from lists. Let's see. So in order to use NumPy, of course, we always import NumPy. By convention, we just call it NP. So NP usually refers to NumPy, import NumPy as NP. And then we create a one-dimensional array like this. Let A be NumPy.array from such a list, 1, 2, 3. It's a one-dimensional list. So after that, we create A as a one-dimensional array, so the rank is 1. We can print the type of A. After that, it will show you that A is a NumPy ND array. So this is the data type in NumPy array. And we can also print A.shape. This means we want to get the shape of A, and it will get you this 3. Note that the shape of NumPy array must be a tuple. So that means the shape must return you something inside the parentheses is a tuple. And how many numbers will be in the tuple? The dimension of the array. Like A is a one-dimensional array, rank 1. Then A's shape will only have one number because the shape indicates the size along each dimension. Since the dimension is 1, of course, you only have one number here. And this number 1, this number 3 represents the size along the dimension. We know that A is 1, 2, 3, right? And the size is just 3. In total, there are 3 elements, so the shape would be 3. And NumPy's convention is that for 1D array, even though it's only 1D, but the shape will be something like this. The size and added with a comma and ended with the right parentheses. So even though it's 1D, it will like something like that instead of the 3 and n. So it will leave this comma here. And we can print 8 elements by accessing them using the square brackets, the index. We get A0, A1, A2, and it will print 1, 2, 3, these 3 elements of 8. We can also change an element of the array. For example, let A0 be 5. After that, if you print A, we will become 5, 2, 3, because we change the first element, that's A0, to 5. So this is a 1D array. Note that if we want to create some multi-dimensional array from lists, we should try nested lists. So this is an example. Let B be such array. As you can see, B is a nested list, right? Inside this list, we have 2 lists, 1, 2, 3, 4, 5, 6. After that, we will create a rank 2 array or 2-dimensional array. So if we print B's shape, B will be 2, 3. In total, there are 2 dimensions. The first dimension, B has size 2. The second dimension, B has size 3. So the shape would be 2, 3. The shape will always be a tuple inside the small parentheses. And we can print the elements of B. Like if we print B00, B01, B10, we will get like 1. Here, this is B00. And this element is B01. And this element is B10. So we can print out the corresponding information. All right. Of course, you can create from the list as a beginner of NumPy, but later on, possibly that's not enough. If you only create the arrays from lists, then you have to first define all the lists. But actually, there are much more functions, smart functions to create arrays. So let's see. If we use this way, A is numpy.022. Then actually that means we will create an array of all zeros with this shape. So the argument means the shape. We let A has shape 22 and all elements are 0. So A will just become such a way 0, 0, 0, 0. This is a 2D array, of course. The shape is 22. Similarly, we have ones, numpy.ones. In this way, you can create an array of all ones. And again, we give the shape 1, 2, and we end up with B like this. We have another one which is called numpy.full. If we use it this way, you need to give 2 parameters. The first is shape. You need to identify, okay, what is the shape of this array? So let it be 2, 2. The second is you need to give the value, the constant value to this array. So that now you will create a constant array full with the value you assigned. Like if we run it like this, the shape 2, 2, the constant value is 7, we will have such an array 7, 7, 7, 7 with the shape 2, 2. An interesting one is called numpy.I. This I is not, it's not the real i's you have. This I means the identity matrix. So if we use this numpy.I, here you only need to give one scalar number as the parameter instead of the shape, because we know the identity matrix, the number of rows must be equal with the number of columns. So you only need to give one number. In this way, it will create a 2 by 2 identity matrix. So the returned array will be 1, 0, 0, 1 like this. It's identity matrix. That means the diagonal elements are 1, all other elements are 0. Now that we also have a useful one called random, which is used to create some random values. So it's numpy.random.random, and you need to give the shape again. So after that, it will create an array filled with some random values. For example, it might print something like this, but of course, if you try by yourself, it should be some other random arrays. Each time, it will run in different ways because it's random. So these are some other functions that you can use to create arrays. So until now, any question regarding how to create arrays using lists and use these functions? Okay, I guess no question for online students also. Great, then let's see the array indexing. Array indexing, the range is quite wide, I mean the difficulty range. Sometimes it's very, very easy. Sometimes it will become so confusing. So it's better to clarify all the confusing points here. Basically, we have these different expressions for the array indexing. Most common is just A, I. I is some integer and positive integer, or at least non-negative integer. If we use this expression AI, and of course A itself is an array, then it means we select elements at index I must be some integer, and note that the index, we always start counting from 0. And another usage is A negative I. Suppose I, again, is some positive integer. Actually, I think during daytime's class, I already asked you what this -1 as index means. And actually, some of you very good, you already know that. Very good. So the formal introduction is that if we use a -1 as index, then it means we select the ith element from the end of the list. So here, sorry, it's not n, it's I. So this is a typo, should be I. Here I is an integer. And the last element in the list is addressed as -1, and the second to last element as -2, and so on. So it means you start from the rightmost to select elements, the end. Here is some slicing index, like AI : J. This means you want to select a range in the array A from AI to AJ. But note that in NumPy, it follows the way of Python is that the starting index is always inclusive, but the ending index is exclusive. So that means it selects elements starting at I and ending at j minus 1. Because the ending index is always exclusive. It does not include the AJ. Then sometimes we can omit the two indexes I and j. For example, A, we directly use a column. Or we use this way, A0 column. If we do not specify the starting index and ending index, then that means we select all elements in the given axis. Just everything from starting to end. Or we omit the starting index, but we specify the ending index, A, I. Then that means we will select elements starting from the very beginning, from the index 0 and going up to index I minus 1, because I is not inclusive here. Last AI to something, then that means we will select elements starting with index I and going to the very last element in the array. So as you can see, the starting index, ending index, we can omit one, or even we can omit two of them. Then another interesting usage is this one. We have two columns. If it only contains one column, then that means slicing. We're selecting a range from which index until which index. But now if we have two columns here, AI, column J, column N, then that means we have a concept named increment step. So this means that we select elements with index I through j. Of course, j is exclusive. So that means from ai to aj minus 1 with some increment n. So every n elements, we select these elements. So later on, I will show you an example. And we also have this thing. Of course, we know if I or j is some negative index as the negative integer at the index, then basically that means we select from the last element back to the front. Now the increment can also be negative. We know the last one should represent the increment, right? Now if the increment is negative, for example, -1, then that means we select all the elements but in reverse order. So increment, if it's negative, simply means that we are selecting the elements in reverse order. All right, these are some general rules about array indexing. Let's see concrete examples. Let's start with some very simple example first. Later on, we will see some confusing ones. So, as we said, the NumPy arrays can be sliced, just like the Python list. Since arrays may be multidimensional, know that you must specify a slice for each dimension of the array if you want to use slicing. For example, now we create a rank 2 array with shape 3, 4. A is like this. We create it from the nested list. Actually, if we write A in the array form, we will say A is like this. The 2D array with shape 3, 4, 3 rows and 4 columns. And next, we use slicing to pull out the sub-array consisting of the first 2 rows and column 1 and 2, create B. So B is such an array with shape 2, 2. B is A. In the first dimension, we select the first 2 rows from 0 to 2. 2 is inclusive. So basically that means we will select the first row and the second row. Then let's see what we operate on the columns, or on the second dimension, we select from 1 to 3. So basically that means we will select column 1 and column 2. And if we refer to A here, the first 2 rows are these 2 rows. But then we narrow down it because in the columns in the second dimension, we will select column 1 and column 2. So at the end, B is such a 2D array, 2, 3, 6, 7. So it's selected from A using the slicing. In each dimension, we need to specify the slicing range. All right, This is about slicing. Here is the interesting thing. A slice of an array actually is a view into the same data. They are the same data. They share the same memory storage. It's just a view. So that means modifying it will modify the original array. Actually, they are the same data. A and B, they refer to the same data, but a view to the original data. So let's say if we print A01, of course it's 2, right? A01 means that row 0, column 1, this element, which is 2. Now we let B00 to be 77. So we want to modify the element of B00 to be 77. B00 is here. Actually, after slicing, B is a view into A. So B00 is the same piece of data as A01 because it sliced from that one. So after we modify the value of B00 to be 77, amazingly, now A01 becomes 77. Because you modify one piece of data, then the other one will also change. Actually, they are the same data. Vice versa. That means now if you modify A's value, and if that value is also in B, then actually B's value will also change. For example, if next, just continue here, if we let A01 to be 88, then B's value will change accordingly. So B00, sorry, not like this, it should be print. So suppose next we print B00, the results will be 88. So change one will change another. They are view into the same data. Yeah, just received a question, I think. Basically, B is a partial shallow copy of A, but not a deep. Yes, you can think of that. It's shallow copy. It's not the deep copy. They are the same data. Yes. This is an easier way about the array indexing. We only cover the slicing. Note that array indexing sometimes may be quite confusing if we consider the striding. Striding is that if we consider the increment step. Here for the striding, the basic slice syntax is I colon J colon K. I is the starting index. J is the stopping index. J is exclusive. We not really go into J. And K is the step. Note that this step, increment step, cannot be 0. If it's 0, then basically just stay forever in the same position. So K cannot be 0. So let's see the example about striding. Suppose we create an array A in this way. Like A basically consists of these 10 integers from 0 to 9. If we print A1 to 7 with increment step 2, it will print this 1, 3, 5. Because we will start with A1, which is 1. And increment is 2. So that means we will select the elements after each 2 elements. So the next one we select is 3. Next one we select is 5. Next one, we are supposed to select 7, but this 7 is exclusive. Because here the ending position is 7 is exclusive. That's why we end up with this 1, 3, 5. Note that, of course, all these I, J, K, they can be negative. But sometimes it's just too confusing. They are negative. So I would like to clarify a little bit. Negative, first let's see what negative I and J means. Negative I and J are interpreted as n plus I and n plus J, where n is the number of elements in the corresponding dimension. So if you see some negative I and negative J, basically you consider it as n plus I and n plus J. Oh, that's the same understanding that actually is from the last element to count. This is relatively easier than what is this negative K. Negative K, the negative increment step means that make the stepping go towards some smaller indices or in reverse order. So let's see, if we use this way, a -2 to 10, then it will print out 8, 9. Because a -2 is the second last element, or actually it will be n plus this I, n, the number of elements, which is 10 here, and I is -2. So basically, a -2 is a8, the second last. So it's here, 8. And to a10, of course, 10 is not inclusive, so actually it can only to a9, so that's why it prints 8, 9. But this is for the negative I and j. And let's see what happens if we use the negative k. For negative k, this is an example, a starting from -3 to 3 with the increment step -1. And this means we start from the third last element, 7, a7 here. We go to a3 here. From this a7 to a3, we let the increment be -1. So we will go towards some smaller indices. So it will be 7, 6, 5, 4, and print out like this. Because this j is always exclusive. You cannot really include it. So negative k, reverse order. Let's see some more challenging examples. Yeah, if you find it confusing, just raise questions. I will try my best to explain that, but sometimes I know it's just quite challenging to explain. It's very weird sometimes. Let's see, what is A1 to 100 to 2? It's 1, 3, 5, 7, 9.
So in Python, it won't be out of index.
It's very strange. It will be, but if you use slicing, it won't be. Here is the slicing, right? Slicing and striding, it won't be. If you directly retrieve A100, it reads arrow because 100 is out of index. If you select from A1 to A100, it won't cause arrow, it's slicing. It's very, very strange. I know it's weird, but that's how they design Python. Very, very weird. The logic, but I will try to explain that, the logic. Yeah, somehow I can understand the logic, but different people may have different understandings. It starts from A1 here, ends at A100 exclusively, but actually it ends here. That means from A10, all the following are empty. So still, if you want to go over from A1 to A100 with increment 2, it will stop here anyway. And all the following, they do not exist. So simply, it outputs this 1, 3, 5, 7, 9. Yes, in slicing and striding, it won't go like outside the index. Very strange, but yeah, try to understand and try to remember it. This is the property of NumPy. And let's see this one. Select A4 to 3 with increment 2. It prints empty array. Starting from A4 is here, goes to A3. You may think that why can't we select one element at least A4? No, we cannot. Because from A4 to A3, if the increment step is positive, then we can only go from the starting index with a larger direction. That is, from A4, we can only go to the right direction. But the ending position is somehow A3. Actually, we can never choose such an element. So that's why it ends with empty. And if we write in this way, yes, this won't cause error. A100 to 200 with increment step 2, still empty, because there is no element from A100 to A200. Simply empty. Such elements do not exist. They won't cause error, just give you an empty array. Yes, I know, somehow strange here. Let's see this one. Basically, it's everything, right? We use 2 columns. The starting and ending we omit here means we want to select everything with the increment negative 2. In this case, we select everything, but in reverse order because the increment is negative. So we will start from the very last element, 9, select the elements every 2 steps. So 9, the next one would be 7, 5, 3, 1. So we will get this 9, 7, 5, 3, 1. And note that if we use alternatively in this way, A from 0 to negative 1 with the increment negative 2, it's the same with the previous one. Because it's also like you want to starting from like a 0 to the very end and in some reverse order with increment step 2. So actually it's the same. But if we use this way, A0, 2, you do not specify the ending index and give negative 2. Everything changed. The result is 0. Actually, it follows the same logic. So if you always refer to the 2 logics here, like the first one is like this, the second one is like this, actually, they all follow these 2 logics, but still you need to spend some time to think about that. So now it starts from A0 to some end. Until now, you don't know the end. It's not like that the end is always the rightmost. It depends on the increment step. If the increment is positive, then you should go from some starting index to the larger direction. You should go to the rightmost. But now, the increment negative 2 is negative integer. When the increment is negative, it means that, follow this logic, negative k makes stepping go towards smaller indices. That means you will go into the leftmost. So if you do not specify the ending position here, it means that it will go from A0 to the leftmost because it goes to the smaller indices, goes to A0. There is only one element, A0, so it prints out 0. So this is the, you may think that's some strange behaviors of indexing, slicing, and striding. So just keep in mind these 2 rules, and you will eventually figure out what is going on in these examples. So let's maybe check some question here. I have question, I print A432 does not print 4. Yes, very good question. So now let's try to explain it using the logic here. Okay, someone said let's try to A0 to negative 1, negative 2, but got an empty list. Oh, sorry, I think I forgot to update it here. Sorry, it should be an empty list. Yeah, I think, that's no wonder I feel it's very strange here. All right, if we use this rule, so actually, yes, you're right, this should be somehow empty. Okay, maybe directly write it here. This should be empty. So let's work on this wrong one maybe first. Starting from A0 to A negative 1, so basically it's from A0 to A9, right? And if we use a negative increment, negative 2, and that means it must go to the smaller index direction. And if we go to the smaller index direction, actually we cannot find such element because from A0 to A9, that's in the direction of the larger indices. So that's why actually you cannot select any element. Yes, actually this is wrong here. Later on I will update that. Yeah, thank you. Thank you for pointing it out. And the remaining question would how, like A423 given 2, does not print 4, actually the same logic here. Because if we go from A4 to A3 with a positive increment 2, then it means we must, starting from the starting index 4, goes to the larger index direction in the to the rightmost way. But there is no such way because the ending position ends here. So it will become empty. Actually, this example here, A4 to 3 with 2, follows the same logic, almost the same example with this one. With this mistaken one, this A0 to -1 with -2. They follow the same way. Like the sign of the increment, whether it's positive or negative, must be in accordance with the range. If it's positive, then the range must starting from some smaller index to the larger index. If it's negative, then it must be from some larger index to smaller index. Otherwise, it just becomes empty because you cannot select such thing. All right, yeah. And why shouldn't A0, -1, -2 include 0 in its list? Yeah, it follows this way because it must be in accordance. The range of the indices must be in accordance with the sign of the increment. If the increment step has a sign that is violating the range, then basically it directly returns empty, like here. From A0 to A -1, actually it's from smaller index to larger index, from 0 to 9. But now the increment is negative. It's not in accordance with each other, so simply return empty. Yes. Yeah, very good. I know it's very confusing. But it's quite interesting. Actually, you can try to type out more examples in Google Colab to see the behavior of array slicing and striding. You'll find that, yeah, really, really, very interesting to figure out the rules here. Any other questions here?
Is all the rule applied same
Index. You mean these two rules for index? Yeah, they only apply for slicing. If it's integer index, the things will change. Yeah, if it's integer indexing, it will be out of index. Like if you retrieve A100 here, it returns error. But it's useful in the syntax of the slicing. So only use in slicing and striding these two rules. Yes, very good one. Yes, please.
Why the last one prints 0, but the one he starts is not 0?
You mean why this one is 0, but the second last one is not 0?
Yeah, that's why I want to ask why in the chat box this one doesn't include 0, but for the last one we is A nothing and -2 includes 0.
Great question. Second last one, the logic is that negative increment must be in accordance with that from larger index to smaller index, otherwise it's empty. And second last question, actually we know that it's from smaller index to larger index with negative increment, so it's empty. But the last one, different. Last one, you do not specify the ending index. You let NumPy to infer what is the ending index. NumPy finds out, oh, you give me the starting index, 0. You give me a negative increment, -2. And NumPy infers that now that you give me a negative increment, then you must want me to go through to the smaller index. So it will find out, okay, then starting from A0, goes to the smaller index way, basically that ends at A0. So that means it only selects A0, this one element, with increment -2. So it gets the element 0. Yeah.
I will ask some further, but I need to draw on the whiteboard. Can I do so?
Yes, sure. Yeah, because actually it's already the answer. Others, if you have anything, please feel free to go. Basically, the remaining thing will be answer some questions. Yes?
Sometimes I ask, like, assume we have 100, right? We start from 0 and we have the